the speed of a motorcycle increases uniformly from 10 meters per second to 15 meters per second in 10 seconds. The rider immediately applies the brakes and brings the motorcycle to rest with a uniform deceleration in 8 seconds. First of all, the question wants us to draw the graph, that is the speed time graph of the motion of this motorcycle, and then to calculate from our graph the acceleration, the deceleration, and the total distance covered. So let's first of all attempt drawing the graph. We have this velocity time graph. The velocity is represented here on the y-axis in meter per second, and then the time in the on the x-axis. Okay, in this case, since the speed increases from 10 to 15, it means that this motorcycle did not start from rest. At time t equals 0, we can give it an initial speed, or we can say let that be our 10 meters per second at t equals 0. So that after 10 seconds, let me put my 10 seconds here, the speed is now 15. Let's take this point as our 15. Plot that against this. So the body starts from this point when the speed is 10. Then we are told that after it has reached that speed of 10, or after it has reached that speed of 15 meters per second from 10, the brakes are suddenly applied to bring the motorcycle to rest in a further 8 seconds. So which means I'm going to add that 8 to 10 because it's a continuous thing. The cyclist did not stop by the wayside and then to try to reapply the brakes. No, while it was in motion, the brakes are applied. That's immediately after 10 seconds. And for the next 8 seconds, the motorbike or motorcycle decelerates uniformly. Uniform deceleration means I'm going to draw this is 18, okay? Because I'm going to add the 8 to this 10 to give me 18, and then I draw the graph of deceleration. This is the graph of uniform deceleration. This is the graph of uniform acceleration. So midway here, I can just take a line from this point here to where the time is 10 seconds. So that to calculate the acceleration, we have to say acceleration is change in velocity over time, or the slope of this graph. The velocity there, final is 15. That's my v. My u is 10. The time taken for the change is 10 seconds. That gives me 5 over 10. That gives me 0.5 meters per second squared, or per square second. So that gives the acceleration of the vehicle. Now the deceleration of the vehicle, I'm still going to use the same formula, v minus u over t, or the slope of this graph. But I must note that this point here, I'll call that the speed here is my initial speed or velocity. Then when the vehicle comes to rest, the speed here is the final, which is 0, because we're told that the vehicle decelerated to rest. So that's my final speed. That gives me 0 minus the speed here, that's 15. In the time of this difference between these two times, 8 seconds. That gives me minus 15 divided by 8. Okay, so that my deceleration, I can now state it excluding the negative sign, is 15 over 8 meters per second. The total distance covered in the course of the journey from the start to the finish. Now we'll come back to this graph. The total distance covered is always given as the area enclosed by this line, this graph line, this line, and this line. Okay, so that forms two different shapes. One of them is a trapezium. That's S1 is trapezium. Then S2, or the second figure there, is a triangle. So total distance travel will go to be the distance covered in the first 10 seconds, which is area of trapezium, plus distance covered in the next 8 seconds, which is area of a triangle. So this is what I'm going to do to arrive at our answer. So that quickly, I'll, I need some space. I come here to find my S1. What's my S1? My S1 is half A plus B times H. That is the formula for calculating the area of a trapezium. And these two sides are my parallel sides. This line and these two vertical lines are my parallel sides. So this 10 and this 15 measured along or against the y-axis. That gives me half into 10 plus 15. The height now is now taken along the time axis. These are the two parallel sides. Of course, you know that this side is not parallel to this. So these are the two parallel sides. So times 10, that gives me S1 is half times 25 times 10. This is given 5. So that S1 is 1.25 meters. 125 meters. So to find S2, area of a triangle, which is half base times height, my base is 8. So that is half times 8. The height there is the same, which is 15. That gives me 4 times 15, which is 60. So my S2 is 60 meters. So the total distance traveled is the sum 125 plus 60. So that gives me 185 meters. So if I'm asked to find the average speed, I'll just divide this 185, total distance traveled, over total time taken, which is 18 seconds.